for today. That will not be a hard job because we have wonderful speakers lined up today that will discuss the consuming as well as the producing side of LDES and their experience with that. Do mind that we will be recording this session. And without further ado, I give the word to Sander van Doorn for a short introduction and welcoming words.
Well, good morning, everyone. I'm very pleased that we have this, that we can bring this community together, and that we have so many people interested in the business side of LDES and the opportunities that LDES can bring in data exchange for the public sector. Well, public sector primarily, but also, of course, in more commercial settings, as we'll see in some of the presentations. LDES is, of course, something that I'm very passionate about, and I also want to take a moment to thank all the speakers that took the time to prepare something for today. I think we have a very nice mix of profiles. I mean, very different applications that will be presented today. I won't go into the agenda because I think it's best that people present their projects for themselves. But yes, I don't want to take too much of your time. But I think with the SEMIC team, the LDES specification is something that we care about, and we want to develop further. This is also why we have a track of ongoing workshops that is still, well, where we're further refining the LDES specification. So for those that are more technical, you can definitely join those working groups as well if you're interested in that. All the information you can find on the Interoperable Europe portal. And I think that is more or less all I want to say at the moment. I think it's more, you're not here to hear me talk. So I will gladly pass on to Griet, who will have much more business things to say about LDES than I could ever do. So please, Griet.
Okay, thank you. So normally you should now see my first slide. Hope this is okay. So the case that I will present, it involves a cooperation between our agency, the Flemish Environment Agency, and another agency of the Flemish government, the Flemish Department of Environment and Spatial Planning. My co-presenter Tom works at that department. So within the Flemish government, there are many entities that manage environmental data, and these data are scattered or distributed over different systems at these different agencies, and they are therefore sometimes difficult to find for the general public. To solve this problem, the Department of Environment and Spatial Planning was asked to make a web-based portal that provides access to all these data. So we need a way to send the data from the different entities to that portal. Many of these data are maps, geographic data, and there we have the OGC standards for exchanging the data. But we also have alphanumeric data, and there we do not yet have a widely adopted standard. And that's where we want to test whether LDES can be suitable for this kind of data. So VMM will provide the alphanumeric data. We are the data service side of the story. What kind of data is it? Well, in Flanders, environmental permit holders must report data about the impact of their activities, and we receive yearly data of emissions to air and water. These data are processed by my colleagues, so they enrich the data, they validate the data, And then we must send them to the Department of Environment and Spatial Planning to be published on the web portal. But before we send them, we map them to some standards. So actually the test case for the LDES was the transfer of the data of the enriched data from our agency to the web portal. But before we publish the enriched data, we map them to shared semantic standards. We have a Flemish standard for air and water quality. It's called Oslo standard. And that is based on international standards, based on the European ODALA project, and also SSN SOSA standards for observation and measurements. We have extended these standards in Flanders with code lists. Code lists are lists with fixed values for certain variables, such as parameter names or chemical substances. So we map the data to these standards and then publish them as a linked data event stream. The advantage for us as a server side is that we don't have to worry so much about synchronization. Once we publish the LDES, all changes are automatically sent to all consumers. Now, the data that in our test case is only yearly updated, but obviously this becomes even more important for more dynamic data sets. Another advantage is that LDES supports standardization and linked data publication. So we can include the information about the standards that we applied when mapping the data before publication. We can include this in the data stream. And then the users or the data consumers can link it with other data sources that are also mapped to the same standard. Another advantage for us is that in principle, LDES supports all use cases. It's to a certain extent use case independent. So we don't need to set up many APIs, but we have one data stream for numerous potential applications. And this should lower our maintenance costs. Obviously, today we have only one consumer, the web portal, but in the future, this might grow. Now I will give the word to my colleague of the Department of Environment and Spatial Planning, Tom, to explain the client side.
Hi, can everybody hear me? Yeah?
Yes.
Okay. I will explain a little bit the client-side implementation of the project. So for us, LDES facilitated synchronization. We have a full local copy that is in sync, working via a pull mechanism, I think. And a big advantage is also that we can start and stop where we left the last time. So it's very robust also. Very easy as a consumer also is that every data packet is immutable. So we don't have to update data that was sent before. We just have to add data and afterwards interpret the data. We can start all over again as many times as we wish. So it's very easy. It's very forgiving actually for the client. And client-side data handling is very simple because of this approach. We approach this also that the data would be eventually consistent. This finally, if all the data is in, it will be a logic whole. The drawback is that there is a little bit more complex client-side code to handle the consistency and the coherence. But the advantages of the eventual consistency and the fact that we don't have to update data that was sent before also evacuates a lot of other complexity. So for us, the advantages of this approach is robustness, fault tolerance, auto recovery. Other advantages, LDES supports standardization and a form of linked data. For us, it's a form of linked data publication. So the client-side local copy is 100% semantic, so we understand the data. Because of LDES, we don't have runtime dependencies on the source and the publisher. and the data provider does not have to implement use case specific services. So we just consume the data and implement our use cases on data of other parties, which is a nice organizational decoupling also. So support of all use cases. Linked data is the richest form of data. We developed our own visualizations and services and derived data products. So we the data that was sent, we have alphanumerical implemented alphanumerical search possibilities, but we also implemented OGC compliant services based on the LDES. So we have different based on the LDES data that we got, we have implemented different dissemination forms of the data. Yeah, so as I said, we have freedom, but also bear the cost of local implementation. But we don't have to ask the data producer to implement services and to support our use cases, actually. So the current implementation can be seen at informatievlaanderen.be. It's slow-moving data, but it can be seen as sensor data. So we implemented SSN SOSA as a data model. We will build applications to handle more dynamic data. The trend towards real-time high-frequency data. For example, we have a lot of for low emission stable systems, we have to gather monitoring data of those stables, and that will be eigenlijk a consistent stream of data. And we also want to implement the industrial emission portal requirement or with this technology. So for us, this case was a test case for the technology, and I think we are rather assured that it will work. And one of the EAPR is a European obligation that we have to implement to publish actually a lot of emission data from the industry that they report to the government. And we will use this technology. We will be enriching LDES with client-side logic to assure more data coherence. So we should implement a little bit more client-side logic, but we also posted feature requests to implement extra features in the server, so quads can be handled. So now it's only triples, I think, but we asked for quads, and quads can add extra information to help us handle consistency over the sent data. So the code that we used can be found there. I think it's open source. Yeah, use it. Do pull requests and promote the approach. I think it's the
Ja, ik denk dan in een short meeting.
That's it. If there are any questions.
Hello. Yeah, I have a question for Griet first, maybe. Is it correct that you mentioned that there's only one LDES for all of the agencies' data that you consume and publish?
Well, actually, there are several. I don't know precisely how much, but it's split up over different streams. But we see it as one, well, data sets of data streams that is interlinked also, because it's always linked to the same permits.
Yeah, I was thinking because it should
air quality is something different, and even in air quality, I think we have sometimes different emission points in one permit holder, so it can be different.
Okay. And maybe for Tom, the client-side implementation, do you store this data in a graph database again, or do you convert it to a
SQL? We made our own implementation for the persistency, and I think that we stored it on S3 in an S3 bucket, and it's packed as Parquet files.
Okay.
And then that's used to transform the data and put it in a virtuoso and publish the data as linked data, but we also publish it to an Elasticsearch. So we can we have high performance search functionalities, and part of the data is also published to GEO servers, OGC compliant web services. So we have actually, based on the linked data that is coming in, we have 3 dissemination forms actually: Elasticsearch, triple storing data, and then the HIS layer, the OGC.
Okay, thank you. It's very interesting to see what you did. I might contact you about it later on.
Okay.
Arne, you had a question as well.
Well, yeah. You have worked with the LDES Java server?
That's for Greet, but yes, they worked with the LDES Java server.
Do you have any sort of advice for somebody who wants to start using it about how to get into it? How did you start using it? Did you start with the documentation? Did you just run it? How did you get warm with it?
We had one project before this project together with Digitaal Vlaanderen, who developed the LDES server, and they helped us setting it up. So I was not personally involved there, but I know there were actually we give them also advice on how to improve the LDES server, because in the beginning it was only possible to publish one data stream with one server, could publish one data stream, so that has changed. So because we were involved so early in the development process, our IT department has gained knowledge, but I must say that they always hire external experts to set up the LDES. And the market is not so big. There are not so many people who actually can do it, which makes it a bit difficult sometimes, but actually it works.
Maybe I can add to it that I have 2 people in my data team that do know Java and do know linked data, and actually I invested in knowledge building of the software, so I internalized the knowledge, and we also do pull requests and have suggestions and want to work on the roadmap of the software. But I think people from Digitaal Vlaanderen should elaborate on the way forward of the software, because that's a little bit unclear for me.
Thank you. Sorry, the door was ringing.
No problem.
Julian, you have another question, and then
Yes.
we will move on to the next speaker.
Thank you. Tom, you mentioned you have some pipelines to move data from S3 buckets into Virtuoso and then to Elasticsearch service. Like these pipelines, how have you built them, and are they available to see how they have been built?
We use NiFi, so the LDES server has 2 implementations, I think, a standalone implementation and as a NiFi module. We use NiFi. Yeah, so that's one part of the answer. The other part of the answer, whether our code and the configuration is available. It's not publicly available, but we are ready to share. So just send me a message and then we will set something up, and then the people that actually build it can share the code, give you the code, explain what they did.
Right, thank you.
Okay, thanks a lot, Tom and Griet. We move on to the next speaker, who is Koenraad Verduin from Movias. Koenraad, are you ready?
Yes, I am ready. Let me try and share my screen. We'll go to presentation mode first. I learned. You should be seeing my screen that says Movias in large on your screen.
Looks good.
Okay, thank you very much. Okay, now I can't. Okay, this here works. Who are you talking to? Just a short introduction. We are a small-time company. The building that you see here is actually our office, not far from Bruges, and we are experienced in mobility with data, innovation, technology. We all have a background in traffic. which will be relevant a bit later in the use case. But we also have a background in data, so we're trying to bring those two together. I'm not trying to make too much of an advertisement here, but at least you know who you're talking to. What have we trying to do? There's a concept called the Traffic Data Space Flanders, which was a part of a project that Movia's worked on for Digital Flanders. And the idea was that in the as-is situation, as you all know, you have many data publishers, you have many different protocols, as many as you have publishers, or even more. And as data consumers, you have to consume all that data, which means you have integration projects left, right, up, and down. And there's no conformity, not on the protocol that you use to transfer the data and not on the data itself, which is an important distinction that I'll get onto in a second. What the goal of that project was, and that's where LDES comes in, is to create, as it were, the universal plug. Is that we can plug in to any data publisher and understand the data, not only because technically it flows from A to B, but also semantically because it follows the same standard. And in that project, and some of those people are actually on the call, I think Ranko is on the call, we had what we call the MacGyver team, who was doing some implementations, because you have two different ways. You have a data publisher that implements that standard straight away, or you have data publishers who convert their existing protocols and their existing standards into what is then becoming the data space for traffic, which consists of a semantic standard, again, Oslo, as we've seen in the previous presentation, and LDES as the transport layer. Now, why traffic? Because traffic is a very specific use case. Now, traffic is a field in which measuring data has been done since the 1960s, 1970s in a very large variety of ways. You have temporary counts, you have bicycle counts, you have more and more ANPR cameras which recognize number plates. You have these loops in the ground. This is from Belgium. If you look into the ground, you will see these. That's counting everything that passes by. You even have things like entry points that count everybody who passes. So there's a wide range of technologies, and there's a wide range of applications, because things like this still happens, believe it or not. There's still people counting manually traffic because they need the data for a very specific goal. It's to do a circulation plan, a mobility plan, impact assessments, you name it. There's a wide variety of use cases where traffic data is useful, and that's both in mobility for control systems, monitoring and evaluations, visualizing traffic, which becomes more and more important, things like real-time dashboarding, map applications, simulations, what-if scenarios, traffic modeling, which expand into not only traffic, but also emission modeling, for instance. And then, yeah, that's outside of mobility. Traffic data has become more and more useful for applications outside of mobility. I think Gerrit can tell you all about the models they use for emission modeling, for which transportation is a large factor. Retail, we have customers in the retail who want to know exactly what the viewing figures are on a out-of-home advertisement billboard. We use traffic data for that. So traffic data is not only collected in a wide variety of ways, but is used for a large number of applications, and has been chosen as, okay, let's try to standardize not just the way we collect it, because different methods have different advantages, but standardize the way that we express that data and the way that we share that data. And for that, there's been an architecture developed, which is a data space. As most people who know data spaces will know, that one big part is missing. There is no control plane. It's the data plane only. And we make a distinction between the data owners, the data providers, the consumers, and the users. But basically what we try to do is we've built LDES building blocks, which are the same building blocks that were referenced in the last presentation. Those are pieces of software that can run either as a Docker container, Java-based, or as NiFi components, an LDES server, and different components that you can use to build a pipeline for an LDES client. Basically, it's an LDES client would then materialized into a triple store or into an SQL database or HTTP out, whatever you want to use. So technically, the transportation layer was built as part of the project, and the vocabulary, the Oslo standard, which builds on linked data, which fits nicely with the LDES protocol as the transportation layer, was built, which means If we talk about traffic counts, we're talking about the same thing. A bicycle is a bicycle and not a two-wheeler and not something else. If we say it's a car means everything under 3.5 tons. So don't say that for me it's a car and for you it's a light truck, it's a van and it's an electric car for you. No, we have the same vocabulary. And then, of course, data is nothing if you can't find it. So Data Vindplaats is the place where you can find those LDES feeds. And the MacGyver team has basically set up a couple of implementations for this. For these organizations, the city of Bruges has exposed the data set which GeoMobility was the provider for. Telram is a crowd science project where about 2,500 permanent measuring points that are fixed on people's windows are being exposed with daily updates through their LDES feed. AWV is the road authority. They have both fixed counting points on bicycle lanes, and they have temporary counts on highways and on the underlying network. You have the city of Antwerp with bicycle lanes. You have Chrysler, who has these smiley signs, you're going too fast. So we're not just counting traffic, but we're also measuring speed. That's all shared through that same infrastructure. And as I said, it's a data layer only, no control plane. It's open data, because all of this data, ultimately the data owner is a public authority. They are obliged to share their data. We've shared the data using LDES with LDES endpoints, and all that data follows the same standard. Now, why do we, as a private company, because we were involved as consultants in helping set up this government project, which is under Digital Flanders, we can't take all the credit for that. There's many, many people who can take credit. A lot of them are in the call. Sander is one of them. Ranko is one of them. Feel free to approach them afterwards. But we can't take credit for that. But as a private company, we were involved in that project, and we saw that there was a gap. And the gap was between sharing data and using data. There is still a big knowledge gap. What you see here is this is the LDES endpoint as it's being published. If you go with a browser to that LDES endpoint, which is normally not the intention, but we had some environmental experts come to us and say, I think it's broken because I surfed to that endpoint and this is what I see. And they can't make any sense of it because they don't have the technical skills. If I then point them to, here are the Wi-Fi, the Wi-Fi components, here is the explication of how you configure the Docker components. I've even had a meeting where it ends up with the city of Bruges saying, I'll send you an Excel file, don't worry. So we saw that, okay, what's the point of sharing all that data in LDES format, nicely standardized, if we can't take it one step further? And that's where the product Gather comes in. It's a Dutch name and it comes from gathering information. What we're trying to do with Gather is basically say that traffic data that's being shared via LDES and the traffic data space, we integrate it, it's automatically integrated. We discover data, where is data, and not just where is a data set, but where is data, which is a big difference. If I say Telram has devices all over the country, it still doesn't tell me whether Telram has a device in my street. So that's what we're trying to discover. And we export the data so you, as an expert user in your field of mobility, can actually work with that data as if you had collected it yourself. So what are we integrating? Well, we're taking the LDES feeds, publishing traffic data, open data, and we're using an LDES client to actually get that data centralized. It's all Oslo conform, which means that it's linked data published via LDES protocol. As it's linked data, we found that the large language model easily understands linked data. And that opened up a few possibilities to close that gap between technical knowledge, data sharing and knowledge sharing. What we've then asked ourselves is, I want to discover what data is available. What if I can ask a large language model to help me discover that data? And what if I don't need to know Sparkle? What if I don't need to know SQL or any of the other query languages? My field of expertise is transportation and mobility, not data. What can we do? Well, we have a product which is currently live, which builds on the foundations of the LDES project that Digital Flanders has done. And currently, under the hood, there's 1.5 billion triples in a triple store, which are being fed daily from all the LDES feeds that are currently live. We have 3 own developed large language models which treat that data. I'll show you in a bit how it's done. We have a front end built around that. We host everything in Europe. Basically, what we're saying here is through this platform, you can access 180 million traffic counts. And that number is growing daily for 15,000 locations. Just a quick number to tell you how big is that in traffic. We've counted 2.4 billion cars. And that number is growing. Now, how do we do this? We're integrating all those LDES feeds in a triple store. There's one orchestrated large language model that talks to the user and that understands and validates the questions. We call it our idiot-proof filter. If the user asks, show me all counts, and it's 180 million counts, there's no way he's going to make sense of that. So we need to understand what is exactly that you're trying to do. We have different sub-large language models that are querying the metadata to understand what is a TARAM. If the user asks, what is a TARAM, we can answer. Different fragments from the LDES feeds. Okay, I want to know just from October, I want to know in this region. That's all handled by different sub-large language models. But once we understand the user's question, there's a large language model that understands the data structure because it can use the Oslo model. It understands the Oslo model. It creates a query, a Sparkle query based on that model, and then displays the resulting data. There's a separate large language model that then understands, okay, this is a number. Give me the total number of bicycles. That's just one number. Make a sentence. The total number of bicycles yesterday was 200 bicycles on this point. This is a large number of rows. Let's create a table. Let's make a chart. That's what the last one does. And this is a short demo. I have it live here as well. If you have some time, I can show you live, but because I know how demonstrations go, I've made some screenshots. The questions are in Dutch, unfortunately, but language is not a problem. But right now we've set it to Dutch, but you can set it to any language you want. The question here is, show me all the bicycle measuring points in Bruges. It's telling you just, I'm looking it up. There's 4 points for which we measured bicycles in Bruges. You can ask about your selection. How many bicycles are here on a Monday between 7 and 9 in the morning? It's looking it up and it tells you, on average, there's 14 bicycles on that measuring point on Monday between 7 and 9. Okay, I've selected 2 more points. I'm asking, show me all the measuring data from the last month. I'm looking it up. Here's a table. You can download that table. If I ask a stupid question like, show me everything, I'm sorry, I don't understand what you mean. Can you make your question more clear? Here are some examples. Show me all measuring points in city X, Y, Z. Show me for every hour of the day the average speed of cars on this road in Antwerp. So the large language model is instructed to give a user who doesn't know the structure of the data, who has no technical skills, to be able to question that data. I can go through a live demo as we speak, which is this. Are you still seeing my screen?
Yes.
Okay. Let's say the city of Hasselt, for instance, which is a city in Limburg, and it will show you all the measuring points that we have. So right now, this is for instance for one city. This is the places for which we have data. And if I asked a simple question, who has counted here? And it's the metadata that's being questioned. It's analyzing my questions and tell me this was done by TARAM. TARAM is also the owner of the data. Can I help you? And I ask how does TARAM work? So we fed it with context data that understands things like what's a loop, what's a rubber loop, what's the advantages of a rubber loop, how does a TARAM work? This is a full explanation, which is coordinated with TARAM. It's a user-friendly traffic counting device. With, okay, the TARAM S2 is the newest sensor. It works with an AI chip, etc., etc., etc. So all that is included as well. So it's not just for the one user who wants to get that data, but it's also a platform for data providers to expose their data, and LDES is being used as the protocol by which we are transporting the data from A to B. That's in short the presentation. I'll leave it on here, but I'll stop sharing my screen because otherwise I can't see any questions. Are there any questions right now? I should also say you can also, if you afterwards you think of a question, send me an email or reach out to me, and I'll answer any questions. But I see that there's already 2 participants raising hands. Can't see who actually.
Cedric.
Yes. First of all, nice.
Thank you.
Second of all, so you use different LLMs to make a Sparkle query. So first understanding the natural language question and going to a Sparkle query. First of all, how big is the model that you use to make this Sparkle query?
Right now, it's a small one. I think it's 6 billion parameters. We've retrained it so the last layers of the large language model is a training that we've done ourselves. It's a self-created large language model starting from open source software. It runs in under 400 milliseconds right now.
Okay. But are there any cases where it produces wrong Sparkle? So you have like a template that says what is Sparkle and how to make it, and then there's a fallback template, probably that if wrong Sparkle is produced, that it will retry.
Yes, we catch any errors on the. Sometimes it creates a Sparkle query with some syntax errors in it. Not much, because we've retrained it and retrained it. Every time we see it, we do some retraining so it improves itself. We have that about once a month, I think. What then happens is that the error is caught, and the question is basically we give to the user feedback, something happened, can you rephrase the question? I must say we've done some effort in retraining that large language model. One retraining session is about 4 or 5 days on a computer with, I think it's 32 gigabytes of GPU memory, so it's quite intensive. But the result is that we have a large language model that can create Sparkle queries very fast without much context.
Mm-hmm. Okay. And did you use a public data set to train it to make a good Sparkle queries?
Yes, the data sets are the LDES feeds from traffic that we have. So right now the model is trained for the traffic Oslo data model. If we were to use a different Oslo model, we would have to do some retraining.
Okay.
What we've done is basically we have a couple of questions and the equivalent Sparkle query. We synthetically created variations on that questions and variations on the Sparkle query with a large language model, an OpenAI hosted large language model, and validate those. And so we have a training set of 3,000 to 4,000 questions and Sparkle queries, and that's what we use to train the custom LLM with. So if tomorrow somebody tells us, here's a data model for water quality, for instance, we manually create 10, 20 questions and the equivalent Sparkle query. We synthetically enhance that and we retrain the large language model.
Mm-hmm. So it works fast because you have heterogeneous data.
Yep. It works fast because we've specifically retrained it on that data.
Okay, yeah.
All right.
And you made ontology first. Oh, sorry.
We have two more other questions, Cedric. So, but go ahead. Go ahead.
With my hand, I will send a mail.
Yeah.
Voilà, perfect. Stan, you were up next.
I live in Ostende, so I can easily come by the place.
Yeah, thank you for the very interesting presentation, and the questions from Cedric already covered one part, the technology and the resources needed for the LLM to be trained. But having a triple store with these billions and billions of measurements, what kind of technology is serving the Sparkle's server? Because
Virtuoso. We're using
yeah.
one triple store Virtuoso, which is highly optimized. Which means highly optimized as in we spent a lot of time specifying all parameters. It's not customized or adapted by us. It's the open source version of Virtuoso. It's running on a server, a Hetzner server in Germany bare metal server that we rent. Our goal is to get an answer to the user within 6 seconds, and that right now, the data set is reaching a size where it's It's becoming a bit of a challenge, but we still have a few options. We could still split out in different databases and do it distributed. We could, as long as we throw money at the server, the speed will increase. Yeah. But we still haven't reached the end of the possibilities with optimizing Virtuoso. Virtuoso as an open source project doesn't have the easiest documentation. But once you get in there, there's a lot of possibilities. We're looking at other triple stores as well. There's this QLever that we're looking into. There's a few others that we're looking into, but right now we're still sticking with Virtuoso. Yeah. And as Peter said, he's experimenting with new ways. So we have one of our employees who's doing a PhD with Peter. And the topic is actually on ways of storing the data that could dramatically increase the performance, which we're looking forward to very much, especially because it's time series data, and I won't go into too much detail. I think Peter can better explain this than I can, perhaps offline, but we're not at the end of the line yet.
Okay, thank you.
We have one more question from Alexandra.
Hello. Thank you very much for the presentation. You referred to data spaces and building blocks, and I just wanted to clarify if with data spaces that you mentioned, you mean the European data spaces, and if you do have specs on building, because the data spaces are quite a big thing now in EU. And the second one is about the building blocks. Are you talking about the OGC building blocks that are trying to convert OGC standards to linked data?
I'll start with the last one. The building blocks is easy. No, we're using the LDES building blocks that were developed by the Flemish government and are open source software. So on GitHub you can find the repositories from Digital Flanders that contain the source code, and they're being published on Docker Hub and on Nexus repository as NiFi components. They're built specifically to either an LDES server to expose the data or components to consume the data from an LDES endpoint. So they're built around LDES. They're LDES components. They're not specifically data space components, but we've used these components to build a data space. And then to go to the first question, the data space project is a Flemish initiative on specifically within traffic community, where about 10 organizations who maintain different forms of open data portals already agreed to conform to this one standard and share it using the same technology. So that means on a data level, we have now a number of open data points, LDES endpoints, which use the same semantic standard and use the same protocol. What is missing is the control plane. There is no organization that governs the data space, and there's no official membership of the data space. That is a part which is lacking in the implementation of the data space.
Is the EU data space?
No, it's an ad hoc data space just done by the Flemish partners.
Okay, maybe it's worth also having a discussion with EU about that, because
Digital Flanders is involved in the Deploy EMDS project. So the European Mobility Data Space and the Flemish data space will be part of the European Mobility Data Space, as Digital Flanders is involved in Deploy EMDS.
Brilliant, thank you very much.
The lines to Europe are open.
Excellent that you managed to agree. Yeah, have organizations to agree to conform to the same standard and do all of that.
Thank you. Great. We'll have to move on to the next speaker. Thanks a lot for your question. Thanks a lot for presenting, Koenraad. Moving on to Cedric de Croo and Alexandra yourself. Giving the floor to you.
Yeah, I will give the floor first to Alexandra, then the producing
All
side.
right.
Should I start then first?
Yes.
Yeah, okay.
Yes.
Okay. Can you see my presentation in presentation mode? Brilliant, thank you.
Perfect.
Okay, so I'm Alexandra Kokinaki from the National Oceanography Centre, the British Oceanographic Data Centre in the UK. And I will talk about the NERC Vocabulary Server, or NVS. Cedric and Mark told me to create a build-up of how our LDES was created. So the NERC Vocabulary Server is a semantic artifact catalog. So semantic artifacts is terminology to actually include all of the ontologies, thesauri, terminologies into one word for standardized hierarchical terminologies used for the management of data in the marine and related domains. NVS stores and shares vocabularies, terms, and relationships between the terms in a human and machine-readable format. NVS is managed by BODC, the British Oceanographic Data Centre at NOC. It receives funding from the Natural Environmental Research Council in the UK and several EU projects. It uses SCOS, and because this is a linked data community, I don't think I need to explain SCOS, I believe. So all of our vocabularies are modeled as SCOS collections, and these collections have terms that are modeled as SCOS concepts, but we also have thesauri that are modeled as concept schemes. So for each collection, we publish a certain amount of metadata that come from different ontologies and vocabularies like the Dublin Core, OWL, SCOS, and RDFS. We publish in different serialization formats like RDF-XML, Turtle, and JSON-LD. And we also support content negotiation and content negotiation by profile. And if you don't use content negotiation, we also have a certain URL to get what you need in your serialization format. As we said before, a SCOS collection has many concepts that are called members in SCOS. And for each concept, again, we store certain metadata that come from, again, ontologies like SCOS, PAV, Dublin Core, like their preferred label, alternative labels, and so on. And we also provide mappings that can be internal and external using ontologies, again, and vocabularies like the RDFS and the SESO. So external mappings are mappings that relate a concept, an NVS concept, to an external ontology like QUDT or term. And internal ones are NVS to NVS. We also have unique identifiers for our mappings. And of course, we publish in different serialization formats. Now, the LDES feed happened because we needed to publicly keep track of changes to our vocabularies. The LDES feed is a new service that we provide and can be accessed. I thought the link was there. VLEIS funded BODC to develop the LDES feed by the Modnet Biology funding. And this new feed gives better detail on what has changed in NVS collections and concepts. Now, our architecture fetches data from our Spark endpoint through a daily Python script that checks for collection changes. If we have changes, it doesn't. If we don't have changes, it does nothing. But if we do, it generates a new fragment. It is validated and then it's copied to our web server. So we actually have produced files so that there is not a lot of load in our Spark endpoint by dynamic creation of those fragments. So an example of a vocabulary's fragments looks like this. So these are several Turtle files of historic fragments by year. So this particular vocabulary was first published in 2008. And then we have historic fragments up until 2024. And then from there, we started updating with daily updates or less frequently, depending on the updates of the vocabulary. Currently, in our production server, we have 301 vocabularies. The number of files is 1066, and in total size, nearly 106 megabytes. That provides full history of all collections available. An example URL is that. So this is a vocabulary, and if you know the vocabularies, you can replace this L22 with a different vocabulary. I don't know if that is very good in your screens, but this is the anatomy of one of our LDES files, where we show a fragment, a latest fragment that is from the 14th of May. So 10th of May to the 14th of May, and it shows that there is a new concept or a new term, the name of the term, the alternative label, the preferred label, and several information about date and versioning. And that's it from me. Do we go to questions or do we go to Cedric's presentation?
I think we can maybe have first round of questions. So it's still fresh in the mind, and people, if there are any, go ahead. I see your hand is still raised. Peter.
Thanks for the presentation. It's really great to see the adoption of LDES by people really just implementing what a server should look like, and just implement it on top of their existing systems. I think that's what it's made for. At this moment, I think you only have a one-dimensional system, right? You only point to the next page. Is that true, or
to the previous?
Or the previous page. Yeah. So you start from we already saw in our tests, like when we run these things, that a far better idea could be to actually have a search tree, so that you first, like on the first page, you would just say, look, I have about these years, I have some data, and then you go deeper into the months, into the days, and so on. Could there be plans in the future to support that? Because that could potentially make replication and synchronization much more efficient.
Yeah, definitely. Because I think the concept is a little bit difficult to grasp initially, so that we can roll it out to the rest of our end users. So maybe such a map to search what is out there and then start consuming it would be even better. Just one more thing that I didn't say in my presentation is that we currently only publish LDES feeds for our concepts without the mappings, because the mappings are really many, and it would heavily impact the feed.
Yeah, interesting.
Jesper, you had a question as well.
Yeah, I really like the idea of the static generation of the data. So you don't need very big machines to answer the Sparkle questions. So my first question is, do you share this Python script you use to generate the
it is Cedric has created that one, and it's publicly available. So
that's great.
Cedric,
that's great.
Yeah.
And the second question is that do you need? I saw when I retrieved this L22 concept that I get a L22 latest TTL file. So is there is that configuration of the web server, or do you need some, or is the web server standard Apache web server or Nginx, or is that an active component?
Apache, and so it is in the Apache, and it is configuration on the server side.
Yeah, it looks really interesting. Yeah, I would love to get this Python script. If you said it's publicly available, it would be great if you could share the link.
Yep.
Yeah, thank you.
Thank you. Cedric, floor is yours.
Okay. So my name is Cedric de Croo, developer at LDES, and I'm going to talk about the consumption of the LDES feeds of BODC. So this will be done through the vocab server widget, which we'll talk about. And we will use these vocab terms, these harvested terms from LDES feeds in a translation management system. But first, why do we do this? For those of you who have been lucky enough to meet Mark and to have a presentation from him, you have probably heard of the Felicity Jones effect, which is when you pose a question to Google, which is like, who is the actress playing the wife of Stephen Hawking? You get some search results, some pages, but you also get the answer on top. And this is great, but it only works for the entertainment industry. The academia lags completely behind this because you cannot ask a question like, what is the amount of copper pots that were present in the North Sea between this and that date and between those temperatures? You will not find an answer. You will have to put a PhD student on that for a few months to get an answer. And that is what we at LDES want to solve by integrating all these semantic web technologies so these questions can be answered quickly. So the graph is being used for that, knowledge graph. And to first help data scientists with this, data scientists, they have this, they have their data, their tabular data in a specific format, but there is not really metadata linked to it. And to help these scientists, we, together with Red Pencil, have developed the vocab server. And the vocab server initially is for harvesting and integrating ontologies to make lookup widgets that can be implemented in different UIs to standardize the way that metadata is inserted. For instance, there is a vocabulary for marine species, for marine regions, the BODC measurements and measurement types are also used. This can be inserted via RDF dump files, but also can be used with LDES. And using LDES is very nice because you can be up to date with all the changes from all these different vocabularies that you choose to use. An example of how we otherwise use all these LDES feeds is with the translation management system. So for instance, the measurements from BODC, they are all in English, as you saw from the small fragment that Alexandra has shown. All these alt labels and descriptions are in English. So what we will set up is language communities to translate all these terms into different languages and to then ourselves publish an LDES feed can be consumed by BODC again, so they can uplift all their data with all these translations that were done. So in short, as an example, BODC provides the LDES feed. You have a consumer, which is not us, which consumes that LDES feed. And for instance, they are interested in English and Italian terms, but right now there are not many Italian terms in BODC, in the vocabularies. And we will consume that same LDES feed and set up a community of Italian translators that will, in their turn, start translating all these terms in batches. And once a batch is completed, we publish a fragment, and this will be done via GitHub pages, just a static fragment, which then by itself can be harvested by BODC, and they can push that out. And the beauty of this and with LDES is that you can choose where you get your data from. It doesn't matter that the Italian translation would then come from our LDES feed or from BODC, because eventually it will end up back at BODC, because we, the consumer of the LDES feed, will become a producer but in the end. So we use linked data to link people to make them link data again. That's the beauty of the whole thing. And in the end, we will have multilingual support for multiple vocabularies. And that's very beautiful that this can be done via LDES. And that is it. Are there any questions for me?
Thank you, Cedric. For now, no hands raised.
No, good for me.
Okay, clear. We can then move to the next one. Thank you, Cedric and Alexandra, for your presentation. Next up is Sven and Peter.
Yes. Hello,
Whoever
everyone.
wants to start first, Sven, go ahead.
I think it's me. I'm going to share my screen. Up. Okay, slideshow.
Yes, perfect.
Cool. So, we at Public, together with Digital Vlaanderen, Flanders Digital Agency, we set up a small proof of concept to consume an LDES feed of addresses. I'm not going to present this all by myself. I have the company here of Peter Jans. He is a manager and architect at the ACR Group, which is our partner, where we set up a data platform, a data mesh platform to be exactly. I'm going to tell you a bit about this platform and why we did it. But first of all, let's take you what Public does as a mission. So we are a non-profit organization subsidized by the Flemish government, and our mission is to let people participate in culture and leisure activities. So we match them, we match events with participants. And we do this in Flanders with a lot of products. We have this event listing site out in Vlaanderen. We have loyalty and discount program. We have a subscription model for musea. We have a central database of all the events. It's like 250,000 events a year in Flanders and Brussels, so it's a lot. And we have a central identifier, an IDP. And all these products we built with one rather big platform. So the core value over there is events, like I said. And we collect a lot of data. To give you an example, it's like 350,000 art passes, 250,000 musea, and we have a typical the infrastructure of a platform with the data layer, infrastructure layer, and so on. But like 2 years ago, together with the Flemish government, we built an exchange platform, and there we like to expand the data sets we are using. So because there are lots of stakeholders in this culture and leisure field. There's this planning software. There are CMSs for organizers, ticketing vendors. We have colleagues, other sectoral organizations. There's library data and so on. And at the moment, they're all in silos. The real problem is we can't aggregate this data to get new insights. So we built a data mesh platform for this. And now I give the floor to Peter, I hope.
Yeah, Sven, I hope you can hear me. Yeah, good morning, everyone. So as Sven indeed explained, we have built a cloud-native data mesh platform. So 3 important topics here. First of all, it's data mesh, which is found by the book of Mark Damani that describes a decentralized approach for sharing data with the concept of product thinking and product design, but then applied to data and therefore building data products. having what we call federated governance that allows automation rules and validations to occur on people building data products, and most importantly, a self-service platform. So that means basically that he or she that wants to share data can do that by himself with a set of controls and a set of tools that allows them to build on that. And I think Sven will show a little bit later a demo of how that's accomplished for the specific use case and to do that. So the data mesh platform exists on different layers. We have what we call the utility plane, where we have built a number of or extended on a number of cloud components to abstract basically that complexity behind. Then we also have created what we call a data mesh experience plane that allows you to define a data product, create basically the code to build that data product, and also deploy. So everything has to do with CI/CD into building and deploying those data products as containers on a Kubernetes platform to enable that. A little bit higher is the data mesh experience plane that allows you to do data discovery. We'll also show a little bit on how we solve that, and also lineage, where we can then have data products attached to each other, what we like to call is source-aligned data products that consume sources of data, and then also potentially aggregating data products that combine the output of other data products into new data products. And to make that observable, we also have different components there to get a good idea of how the data products are running, and also the policies that apply in that. And finally, some of the applications to provide end-user applications to onboard, for example, to have insights and to do some machine learning on that. As I explained already a little bit, so the platform has been mainly composed on Kubernetes. We also have extended that with some custom resource definitions, and really focused on having a decentralized ownership possible via that service, self-service platform. Some of the capabilities that we've introduced in the platform is the ability to create input ports, have different data transformation types, for example, in Python or Java or PHP, different programming language that you may choose, different output port types, and then everything to support that basically, and integrating with a number of data technologies to support a complete platform. Now, what does it mean today to have somebody build what we call a data product? So somebody can onboard via the small application that was created, where you can input some basic information, and then he will get basically a Git repository with a template of source files that he can then extend. And this is the start, what we like to call then, of the data product journey. The first part is indeed, so the Git repo contains a number of components. It will do that by providing a data product YAML code that we can use for the Python, and then also some of the requirements text file and procedure file. The metadata then allows you to define all your input ports and output ports and all of the metadata that you want to extend on top of that. And then effectively the code. So the transformation code that you want to write, and that we've also done here in this use case to enable that. And then in the end, of course, the actual data that can be extended or provided on a S3 bucket or a REST endpoint that can be consumed on that point. So in this proof of concept, an LDES output has been created just as an example to show how we can consume basically an LDES output as an input port for a given data product. And that is something we've defined and can be either implemented as a source file, so where the component is in the input part, or the component is in the output part, where it's an LDES server that we then reuse or extend on that.
Okay. So like these steps Peter already mentioned, I'm going to take you through these steps and use an LDES feed as an input port. Like Peter mentioned, we used the addresses LDES feed. It's very important for the public as a platform that we have the right addresses with all the merges of the Flanders, of the communities in Flanders, for example. and all the changes. It's very important that our participants get on the right place, of course. Yeah, these are the steps. I was going to show you a demo, but I'm going to take you through some screenshots because I think these are the same. So I created the data product YAML file, where you have some metadata, and also, like, for example, the cron job, if you see it, like on the cron job to run the transformer code. There is no, the platform does not have any capability yet for an LDES feed. So, like, for import ports, you don't have, we have only the name. And I wrote the logic to import the LDES feed by myself. But for the output port, I chose an analytical database. It's a ClickHouse database. So first of all, you define the URL, and then it's very, it's really easy Python code to fetch the LDES page, to parse the LDES feed, and you have a graph over them. In this graph, you can on this graph you can do a SparkQL query, and this SparkQL query you can load in this ClickHouse data environment. If you then run the transformation code locally with the CLI, you get and you defined an analytical database as an output port. You can get immediately a localhost play environment in ClickHouse, where you can do some select and some data browsing. If everything runs well locally, and like to give you an insight, we have this, like, this code is like not even 100 lines of Python code. And you can choose Java and PHP as well. If you upload your repo, then the data product will appear in the data catalog. We use Data Hub for that. There you have the demo Sven data product. And you can check the logs when does the transformation code load, and run, and also get use the ClickHouse analytical database on a test of production environment as well. And then you can connect your Tableau, your Power BI, or whatever tools you want. Okay, so what are the findings of this POC? It gives a really added value for us to get the latest version of your data, the latest version of this address I already mentioned. We think it also has a lot of possibilities for streaming data, like web analytics. We get a lot of insights from all these products, the user journeys, etc., that we can reuse in other products like a recommender. Once again, all over this silos in, because we're not the only product in Flanders on the culture and leisure field. And also, this is really important. This new platform has only value when there are data sets on. So we think this is a really fast way to get extra data sets on the platform. These data sets are really, these LDES feeds are really standardized, already standardized. These have already this metadata, etc. So we're following up this LDES feeds closely. But I was really I was confronted with some, once again, with the extra complexity of an LDES feed, like the graph data, the versioning, the paging, etc. We do not use that's really a disclaimer. We did not use the building blocks of VSDS in this POC. But like to abstract this complexity, I think we have to think. in the future we have to think about using these building blocks as well. There are some doubts about performance on big data sets, but yeah, we didn't use this big data sets in this POC. And yeah, we are using event sourcing at Public as well with RabbitMQ and Kafka. There's a lot of tooling to build event sourced systems. And we still think, yeah, there's a lack of tooling, possible lack of tooling on LDES. But still, yeah, it has a lot of advantages as well. And for us, like the greatest plus is the discovery of new use cases. So when we get real-time updates of authentic addresses, yeah, we can cross-reference it with the location. But also, like, there's a lot of infrastructure and facilities for sports and recreation in a database or associations as well. So if we can do reconciliation on these different data products, we think that there will rise new use cases to make data products, for example, for policy decisions or for policy implementation. Yeah, if we can cross this with energy regulation, the EPC values in Flanders, or mobility planning, or environmental planning, etc. We will rise some use cases on the slide here. The drawing is in Dutch, but on insights to get more interaction with our users, to get more inspection for policy making, and even some new products, some innovation acceleration as well. And yeah, that's, I hope I will be in time, but yeah, that is our short presentation, and more info you can have on outwissingsplatform.be.
Thank you, Sven and Peter. Any questions for our speakers? Being to pronounce it correctly.
Pronounce my name correctly. It's a really good presentation, and I'm very happy that you are using the Data Hub, because we were also looking at this solution, the Data Hub for the metadata. My question is, if the metadata you are presenting on the Data Hub is is manual input, or you crawl it from the LDES feed? Like how the data is available on the Data Hub portal?
Yeah. Peter, or
yep.
Yes,
well, I can take the question. What we, as I explained in the data product, we have a specification of the data product, which is written in a YAML file. And that basically, that input that's in the YAML file then basically is transported towards the configuration of Data Hub. So it then allows you to have the lineage, for example, and all the other information that we have within the YAML file as visible as all the properties and attributes and components in Data Hub.
So it's manually, yeah.
Yeah.
And if I can jump in, what we also are planning on working on in the next months is being conformant with the DCAT application profile, so the metadata of catalogs, digital catalogs, which would also be information that we get from this config YAML file as well, but we have to expand on it. And this is also something that the DCAT does not take into account the concepts of a data mesh with the lineage of a data set that's connected to another one. And there's an ontology dprod that builds on top of it. And I have been in contact with some of the people here in the meeting, I think Jits as well. It would be very interesting for us to also have that information, the lineage of data products, instead of just a catalog of data sets where you don't see the links between them. So this is a project that we will be working on in the months to come.
Okay. Because we also look at like using DCAT to represent the metadata and get it published on the Data Hub. If you can share your fund after, will be great. Thank you.
Okay.
Peter.
Yes, thanks for the presentation. It's again something I wasn't aware of, and that always blows my mind from the moment that people actually did stuff with LDES without me knowing about it at all. So I'm really excited about this. About all these things happening. You presented on your slide, like in the negative points, like something that really triggers me is a doubt on big data sets. Of course, I certainly want to get rid of any fear, uncertainty, and doubt about potentially LDES here. And I'm wondering, like, what is triggered by this performance on big data sets, because we have a lot of tooling to make sure that big data sets will work in the end, and we also are doing performance tests in that direction, and big data sets tend to perform well. We're also like working a little bit in like a slow project, a hobby project almost that we're doing, a side project, is trying to get full OpenStreetMap in LDES, just to prove our point that really big data sets work really well. The problem is that getting OpenStreetMap on a machine, or getting a machine that is big enough to host OpenStreetMap, is also already a budget issue. So there we're struggling a bit, but that's with handling OpenStreetMap in general. So I'm wondering here, what's your doubt exactly on the performance?
I'm very happy, Peter, to hear this. I have to be honest, like, yeah, we're subsidized, so we follow public tendering. And for the project Stan already mentioned, where we also going to implement DCAT, yeah, we had a public tender for that. And there were some partners who said, yeah, watch out for big data sets and streaming data, because we're not sure about all the the performance and the stability. But let's prove them that I'm wrong.
Maybe if I can also elaborate, because also, what I would like to point out is maybe something that Koenraad said in a previous talk. To LDES or not to LDES, what data sets are what's a good data set to use an LDES feed for? And I would think that it's like the addresses or buildings or OpenStreetMaps or data sets that are not likely to have a lot of changes or a lot of fluidity in them. Or not really, correct me if I'm wrong, but I'm also thinking that the events or participations can be something that is very fluid and changes a lot, and having immutable objects of all of these very fluid objects can become very big and very cumbersome for someone consuming it, and then not as interested in the version objects, but just in the objects themselves. It'll become cumbersome to consume this data. That's I think also the issue that we are thinking about. What data sets are appropriate for LDES and what are just more interesting to have a Sparkle endpoint with the finite object in it without all the history.
So it's not about LDES in specific, but more about streams in general. I understand, and then of course I think you can. When handling streams, it's actually very simple how to deal with the large amounts of data. You either say, I don't store all the data, and you put a retention policy on it, which is something that LDES also then can make transparent. Like, look, this server does not keep all the data. We only keep the latest version subset, for example. So only the last version of entities that you can use in order to take a full copy at that moment of it. Now with the new spec coming up, we're actually discussing the new spec. I mean the update of the spec coming up. We're actually working on more elaborate retention policies there as well. And I think a second big thing is, of course, in LDES that we paginate, that we allow to have this chronological search tree, for example. This is really powerful because it scales logarithmically deeply in the depth and in that sense. So you can really work that use that to your advantage. And then a third thing, what you can do is, for example, the data in its fullest, with all the triples attached to it and so on, can be quite verbose. And then it's in initial stage. You could say, look, we only keep that data for 1 hour, for example, which might be useful in traffic measurements, for example. But then you listen in with a processor on it, and then you immediately create an aggregated version, like you create a day summary of or a per hour summary about it. So in that sense, aggregation, pagination, and retention policies, these are your 3 biggest tools in order to work with big streams in that sense. And you may always need to make a trade-off, like from the moment that you have a retention policy, it means some use cases won't become possible because you're removing data at a certain point. With pagination, it means that you're optimizing for a specific kind of traversing. And with aggregation, same thing. You will remove certain use cases that become possible. But these are the trade-offs that we need to make as data engineers in that sense. Handling big data comes with trade-offs that you need to make in that sense.
Yeah. Okay. No, thanks a lot. I think this emphasis that we're in the early we're in the starting phase now of our project, and we're still learning these things. This is really good information. This really helpful information for us.
Yeah. Because on your next presentations, I don't want to see any doubt on big data sets. I want to see LDES even supports big data sets, because we put a lot of effort in that. So yeah.
If you have some problems, Peter, I will call you.
Perfect. Yeah, my phone is always open for you, of course, and my door is confusing proverbs there. Yeah, but good. There's some questions in the chat by Harmjan.
Jan, would you like to, or Harmjan, would you like to throw them in the discussion here, or?
So the question there was basically one: is the Eclipse data space protocol being integrated or tested there? And I know there is some effort there, but I'm not fully on. I think other people in the call might be more aware. Ranko, maybe?
I think I'm actually more aware than Ranko can pick up as well.
Okay.
But just to say that we've done integration testing with EDC connector, but has stopped. We were compliant as the data level with the EDC connector, which is documented as Sander puts there with the link. Problem is that we have not maintained an upwards compatibility with the latest version of that EDC connector. So you have to look at what version of the EDC connector you're using.
Okay, thank you. And can you provide a link?
Yeah, the link is in the chat. Sander put it in chat.
Yes, and I just quickly want to add, because in the end, LDES is just HTTP. It's just a bunch of HTTP requests, and there is only GET requests going from the client to the server. Carrying this over the data plane in the EDC connector is, as such, not incredibly complicated, since it's quite standard in that sense.
I was expecting, yes. Good. And then the other question is on MCP. I'm not sure if I am getting into more new protocol areas, but okay, ciao.
But the MCP is so a industry-driven, more an industry-driven specification that would allow AI products to connect to certain system. I think it's certainly possible to just attach the LDES client there somewhere, but I'm not aware of any efforts in that direction so far. But maybe it's maybe if you have some interest there, maybe it's something that you can contribute in the next community session. Okay. I don't know.
I think it
MCP
makes
is, of
sense.
course, the next big thing, and also we are looking into different places where we can implement that, given a specific use case. But we haven't touched that specifically for this data mesh platform.
Okay, so my background for these questions are related to digital twin. We are just starting a local digital twin project in the City First program for sustainable travel, living, and mobility. And I'm currently working on the architecture and interoperability test bed. So yeah. So I expect MCP will become a handy tool. And but on the digital twin, if we have about the geodata, I think OGC has some APIs currently that might be also a good match with the work that has been done here.
If I may chime in, I remember from the days that we're working on the VSS components that one of the issues with the EDC was the problem that on the HTTP plane, they wouldn't allow us to have custom headers. And we needed those custom headers to do, basically to do the LDES requirement of telling when a page is final, or at least, it's stable, let's put it that way. But with the new specifications coming up, the changes that we're doing in the LDES community group, these things will be in the file itself. So we will know in the file itself when when the content is pretty much stable, or when you need to refresh that particular page in order to know when new data is available. So that opens possibilities with the EDC connector as it standard at that time. And we'll have to look into the newer versions to see if that's still available. But that was one of the issues with the HTTP plane, basically.
Oh, thanks.
Yeah.
All right. Thanks all. Peter, I see you have your hand raised, but that was maybe still for the previous one. Okay, I suggest we move on to our final speaker, and that's Stefanie Kerkhoff. Stefanie, are you there?
Yes, hi. I have to share my screen. That should be okay, I guess.
Yes, perfect. Thank you.
Yes, great. Yeah, so I'm the last one, so bear with me, and I may be a little bit of an odd one out. So no terms like Docker, Virtuoso, Java, whatever for me. I'm going to tackle this from a business side. So what have we done? Also in Flanders with the Agency of Home Affairs and Digital Flanders, we have used LDES to make the single digital gateway happen for local communities in Flanders. So this is your Europe. I don't know if you guys are familiar with it, but there's a regulatory that states that all European governments, also local governments, should provide information on this website. And in Flanders, we used LDES to get the information on there. What kind of information are we providing to that website? It's looking something like this. So it's I guess another kind of data set. It's really explaining on what products and services citizens or entrepreneurs can get from our local government. So this is an example on Kids ID. It has a description, it has some metadata, what requirements that citizens should fulfill to get this product and the validity period of it, what procedure they should be following up on, and so on and so on. The supporting documents they should bring, how much it costs. So that can differ for every local government in Flanders. So every local government provides this kind of information on several of their products and services. We have about 15,000 products and services that are being published to your Europe at this point this way. Oh yeah, this even goes on a little bit more, but that's the data we are providing. Why did we choose to use LDES? First of all, because our colleagues of the Flemish Smart Data Space were working on LDES, but also because we had to gather quite a few data sets from different communities and cities and provinces, and they all are their own competent or executing authorities, so they are in charge of providing that information, and we wanted to keep the information decentralized at its source. So that's why we chose LDES to try if it would work for these kinds of data sets as well. And so far it does. Where we are using it for 2 years now, and so far so good, with little struggles, but I will get back to that. Also, we chose LDES because at the Agency of Home Affairs, we already have a ecosystem view on data for local governments for over 10 years now, that we want to facilitate and support local governments to create and share their data so that it can be used and reused in efficient way. And we focus on data and information that is in their local decisions. So every local government, every government makes decisions almost every day. These kinds of decisions can provide a lot of valuable information, for instance, for publishing on Your Europe. And we wanted to reuse that information in an efficient way. So yeah, we already had something we call the intergovernmental products and services catalog in Flanders, and we added a local variant for every community, so that allows us to have readable information both for humans and machines on all our products and services in Flanders. So local authorities have the guarantee that it will be reused, but keep the ownership on the data. Everybody can reuse that data whatever way they want. And our citizens, our nonprofit organizations, entrepreneurs, they have the certainty that they have always reliable, up-to-date information, even if it is shown on different places and not only on the local website of the government itself. How do we do that? We started with providing some generic information, like the 285 local governments. They all should provide the Kids ID that I showed as an example. So a lot of information is the same, whether it is for Bruges or Ghent or another city. But then again, they can choose how much they charge. They can choose what the procedure might be to get the Kids ID. So we try to provide the generic information. We got that to an IPC, to the Intergovernmental Products and Services Catalog. And from there on, we provided it for every single local authority to be enriched with their specific local information. And then we share it back to the central database. And from there, we give it to, for example, your Europe, but also to several other front-end solutions that are already being used. And local governments, for example, use it for their own websites as well. And where does LDES come in? It comes in there. So we have a producer on the intergovernmental side. We have a consumer on the local products and services catalog site, and it has a consumer at producer at its turn again to reproduce the data or to give it back to the central database. So that's how we have set it up. We have now 13 local governments from the 285 that are sharing their data through LDES with us and counting. So there's a few more that are looking into setting up the data stream this way. I think that's all for this. Oh yeah, we do send data, or the data is not being sent to your Europe itself by LDES. they use an SDG scraper. So that might be something that we want to challenge other European users to also use LDES for, but that might be something in the future. Yeah, I have marked on this slide 3 places with a little red star. So this is to show that 13 local governments are using LDES to provide their data towards Europe by using LDES. If you guys want to know what implementation model or what semantic model we used, the link will be behind the little Oslo word here. Then you can look into that as well. And if you want to browse through all the information that we are providing this way, the link to the front end of the products and services catalog is here. I'm not gonna go into that now because we are already a little bit behind, I guess. To LDES or not to LDES? I heard somebody else ask the question also. I think we are on the pro side for using LDES for these kinds of data because we keep it decentralized as its source, and that's what we really want to support. It is pretty easy to centralize it and give an overview to whoever wants it to, and we for sure have the value of the linked data in the provenance. We do struggle with the use of LDES with local governments for this kind of data because we are talking to, I guess, a different sort of or different target group than that the ones that are usually acquainted with LDES. So there's a bit of resistance to use LDES. They rather would have used REST APIs, but then again, once they are using it, the resistance is gone. So there's also quite a steep learning curve to get them involved. And we do encounter some fragilities in case of changes. And since I'm not technical, I think you all will want to know what fragilities, but then I will have to get back to you. Or maybe if Niels, who is in the call, has more insights, he can pitch in, but we do encounter, like, for instance, the city of Ghent has made some changes on their producer side that we were not expecting. So our consumer was, yeah, he didn't understand anymore. But Niels, yeah, pitch in if you want to.
I can pitch in there. Yes, there's several changes. Well, so first of all, I think a main thing as a consumer that can always happen is if the server side decides to change something and you're not aware, issues are to be expected, which is what happened specifically for this case of Ghent.
Mm-hmm.
I think they switched to a newer version of VSDS and also enabled a retention policy, but then our client didn't handle that well. So yeah, we noticed that pretty quickly because the consuming stopped, and we noticed that no more updates were coming in. But that did require us to have a look at the client. I think we had to update the client to support the newer retention policies. So that was an issue we had in the case of Ghent. Other changes are typically user errors. I know for some of the cities, changes to the JSON LD context were made, and we ended up with incorrect data in the feed because of that. These are, I think, things we could catch with better validation, both on the producer and the consumer side. Hope that clarifies.
Yeah, thank you for helping me out on those topics.
Very welcome.
But yeah, as I said, we have been using this for about 2 years now, but we are still learning and still figuring out also how to provide information to the local community or local governments in a way that they can actually use it easily. So that brings me almost to my last slide. We did feel that collaboration and support was key. So we actively supported our software suppliers that wanted to use LDES. We did weekly get-togethers in the time we were setting up. And up until now, we do quarterly get-togethers with all interested parties so they can share insights with each other. We have made agreements, but then, for instance, we didn't make the agreement that if you go to the newer version of the VSDS LDES, you should maybe let us know beforehand and vice versa. So that's something we learned along the way. And we also have made a specific guidebook. So for this use case, the LDES use in local products and services data, it's in Dutch, but you can always take a look. And what's in there is like an example of how the triples might look, and then with all numbers who explain a little bit further on what people that want to use LDES to provide these kinds of data within or towards the Flemish government. So every number has a little recommendation or something to be aware of, or something that they should have kept in mind, and how to use it, and so on. So that's on GitHub. And yeah, that was that for us. So if you guys have questions, Niels is here to help if it gets technical. But I hope it gave a little bit of an insight on how to, or how we use LDES for like qualitative data and not really quantitative sensor-like data.
Definitely. Thanks a lot, Stephanie. Niels. Peter, I see you have your hand raised.
Yes. First, I wanted to comment on what Niels said towards the prone to changes and things like that. I think that should not have happened, but it did, because it's our big ambition in LDES to make sure that of course that we provide an evolvable specification, that it will be backwards compatible forever, so that if you code against it today, that it will work in 10 years as well. The only problem is that, the previous version of the spec that you also implemented, which is of course good, it has semantics and things like that, but it was very, very fluffy still, and it still had a lot of implementation changes that could be done. I think now with the rewrite of the spec that is going on, I think this is really an ambition that we should phrase every time that we start a new workshop, is that, look, everyone, we want to make sure that if someone builds a client, that it will remain functional for the next 10 years at least, and make sure that these kind of things do not happen again. So I'm sorry it happened. It happened there, but I think we, through standardization, what we are doing at this moment, we are actually going to solve that. Yeah. Then I was triggered.
So I think somebody
You're going on
muted
mute,
Peter.
Oh yeah, I did it myself by pushing the wrong button. Okay, yeah. So something that also triggered me, and something what you said, Stephanie, was I would rather have a REST API that some of your
I would not have rather have
that you had people that would rather have worked that way.
Yeah.
Yeah. So that's also how I understood it. But that's always interesting, right? Because because if you decide on building on we want the REST API, your problems only start there, right? You still need to make a lot of design decisions starting from that point. And I think LDES, when we started designing LDES, it was our goal to build the best possible REST API in that sense. Like it uses hypermedia, it uses HTTP requests. It works as good as possible within the REST constraints. In fact,
I think it's a question of unknown and unloved, because the ones that started using it now, they don't have the same restrictions anymore. They understand, and they are going along with us now. But Niels?
If I could jump in there to also clarify a bit, I think it's also a question of publishing the data yourself versus pushing your data somewhere. And that was a friction that we were experiencing. They were mostly like, oh, but if we have to give you the data, just give us an API we can push it to. And when we said, no, but we expect you to publish your own data, and then we'll fetch it, it's a different set of mind. And I think the friction was mostly there.
Interesting.
And for ABB, ownership of the data, I think Stephanie said that really well, is very important. We want them to take ownership of their own data. So, and that was also part of that friction, I think.
Yeah, really interesting. Yeah. A final thing I wanted to add here is that what I've heard you say is like, oh look, we've now implemented it for the first time for EPDC use cases, or with CPSV. I think I recognized, and I heard you say that okay, so it would be nice if others would follow our example, because of course that would make sure that across Europe, that if everyone does it this way, then we have more interoperability as well, from the technical level to the semantic level, and so on.
Yeah, it was just a little I don't know, a little pitch towards because SEMIC is European, but then again the regulation of single digital gateway is European too. And I know at the moment that the single digital gateway regulation was written, then LDES, I don't think we already talked about it. But it might be nice to see evolvement on that side too, that like a big platform as your Europe, or aiming to be a rather big platform as your Europe, also supports LDES. Because we do encounter some difficulties with the scraper they use, because we have a lot of data. We have like over 15,000 products and services, because the way Flanders is structured, it is what it is, or Flemish government is structured, it is what it is. But yeah, we do feel that it might be a good evolvement if your Europe would also look into LDES to fetch and reuse the data.
Yeah. That's actually something very useful for the SEMIC team to let's note that down, and let's reach out.
That's why I threw it your way to take up on it or not, whatever.
Yeah, great. And in that regards, I also have like a shout out to everyone in that in that regards, that maybe it might be useful to like work on implementation reports. Like if you've built something and you've still taken decisions within how you designed your LDES, and you would like to others in your domain to also adopt this way of producing an LDES, because it contains a couple of good practices that you like and that you would like to put forward. We now have a repository as well. I posted it in the chat on the SEMIC EU LDES implementation reports. So it would be cool to there start having more and more implementation reports, so that people that say like, I want to build a taxonomy for I cannot pronounce it. Sorry, about the oceans. Then please implement it this way as well. So all the use cases that we saw here, I would love that there would be some kind of report there that just details like, look, these are the decisions that we've taken that we think would be good ideas. I'll now leave the closing words to I think Isabeau, right?
Yep. Indeed, we have one more minute to close. I'm happy to see that there were so many interactions and discussions for the speakers between the participants as well. I'm sharing quickly some communication channels. If you have any more questions, if you want to discuss, we have the GitHub link. I've also shared it in the chat. The Matrix channel for directly chatting with the community. And if you want to follow up on working groups on and receive reports, perhaps you've noticed or you attended this workshop via LinkedIn post, but you're not already registered in our LDES mailing list, leave your email address in the chat. Next, some promotion for the SEMIC 25 conference in Copenhagen from 25th to 26th of November. The registration details will be shared mid-June, but you can mark your agenda already for the event where we will have an LDES workshop as well. And then that's all. I want to thank all of the speakers. Thank you everyone for your interactions, for your time, yeah, I'm wishing you the best, a wonderful day, and see you later. Thanks all.
Thank you.
Thank you very much.
Bye bye.
Thanks.
Thank you.